We're back live. Hi. Like I said, one quick meeting done. And we are back to removing the demons from RL. Oops, let me reply to one message first. All right. We should be good. Stream on. Oh yeah, we're good. Okay. So Spencer's gonna be back in not very long. And he is going to be with have the fixes I requested for GPU drive, and then we will debug that. Let me make sure I don't miss messages from him. Yeah, and in the meantime, we will go back to hyperparam shenanigans. In fact, I think it looks like we have some runs here. Yeah, 126 runs. Perfect. So this was just running the whole time. And we can see that the vast majority of these got stuck way down here. So let's figure out why that happens. Right, so this is where the issue is. Let me explain a little bit what is going on right here. So the main issue that we've been having is that the hyperparam sweep tries to run really short experiments for some reason, even though it's expressly designed not to do that. Like that's a common issue that literally algorithm was designed to prevent happening. So I don't know why this is happening. We're gonna figure that out right now. Exceptions. Are we in the right branch? No config for breakout. Yeah, so this is going to run one experiment, and then it will hit our breakpoint. And fix up this API stuff in the meanwhile. We moved exceptions into the main package to make it just easier. Hang on, let me just address one thing. I have a couple messages. Take care of them. We'll get back to this 1 second. My bad, guys. I just have every so often I get random client messages that I have to go back and forth on. All right, so we did hit this breakpoint. Target is 0.4. Cool. It just picks a random number. So this is trying to be 40%. So we should expect this to be 40% of the way between 20 mil and 80 mil. So this is going to be 50 mil-ish. Is that good math? No, that's not good math at all. 30, 40-ish mil maybe. Yeah, 40-ish mil. Lots of... I've just been context switching all day, so you know, hopping around on 2 different technical projects and a bunch of different messages. But the thing that I am trying to figure out at the moment is just why the sweep doesn't work. If we get the sweep working today, we'll be in a good spot because that kind of unblocks us on everything else in Puffer. I think that conversation's wrapped. Hopefully. Whoever's still there watching after I've been doing this for the last 20 minutes, thank you. We will be back to your regularly scheduled RL content for the next bit. Okay. The weight is 0.4. Target. Or no, target is 0.4. GP log C norm. Min is negative. Max is a bit over 1. So, okay, that gives us suggestion scores. And now we have our index. BPC, best index, is 19. 19 seconds. That seems low, right? $1.4 mil, 19 seconds should be like 30-ish mil, maybe? Can I just unnormalize this thing? Wait, it's in this space, right? GP log C norm. So then it's like 0.4 log C max minus log min plus. And then it's exp of this. 23. That's not far off. We suggested 23 and we get GPC of 19. It's a little low. It's a little low when you would expect it to be high, right? Because you're multiplying by GPY norm. You're taking score times the distance from the predicted cost. So higher scoring would be higher cost. Okay, so that's kind of weird. I'm trying to think how we debug this. I mean, it's like not impossible that this result is what you'd get, but like overall, this is not what you expect from a sweep. It should not be running this many low cost runs. It should be like roughly evenly distributed. I guess why don't we check what GPY norm is at that index, right? Wait, what? GPY norm. That doesn't make any sense, right? This doesn't make any sense at all because that shouldn't be maximized. They're all negative? Well, maybe that's the issue. Hang on. Oh, -1. What? Hang on. Optimize. Oh my gosh. How tired was I when I wrote that? Okay. Okay. That's such a dumb bug. I was literally minimizing instead of maximizing. That's a classic. Okay. We'll run a few little experiments on this. Cool. So that should be something. That is Spencer messaging me that he's going to be a little bit longer. Cool. I got dinner at 6. But I will be back after that in case he's not done before then. All right, so we'll let this run a few quick experiments. And we will essentially just see whether this does the correct thing. So yeah, if you maximize instead of minimize, I'm surprised it actually did anything in that case. That's kind of ridiculous. Oh, you know what that is? It tries to push to the min or the max, right? Because like, yeah, that's why there are like a few experiments like way up high, and then it's probably just trying to push all the way up or all the way down. Something like that. Okay. So, lo and behold, this is running for a long amount of time. If anything, now this probably biases to be too high. Actually, hang on. Was that in... How long has that been there? How long has that bug been there? It would just be in sweeps, right? In hyperparams? Okay, so this was correct here. This was just an introduced bug when I screwed this up. So we had this working correctly in all of our earlier tests. All of them are fine. The algorithm is completely valid. It's just that we screwed this up in the most recent cleanup patch. It's just fine. So what's this? This is 80 mil and then 78 mil, and then it went up to 96 mil. And now it's doing like a 20 mil. 25 mil, yeah, that's fine. We'll see if it does a bunch of those. I'll be surprised if it still does this. "20" should be like a 30 mil. Hmm. Okay, now I'm starting to get suspicious. It should be picking pretty much randomly in this range. Okay. So, I mean, this is now what I'd expect, but now it's like... Now it does feel like it's going to the high end or the low end completely, right? I mean, this is like the clearest possible objective, though. It's pick a experiment length, try to run something that's near that length, but also try to run something that is high score. That's all it is. Okay, now biasing towards high score here, if it's going to start doing that, is actually more reasonable. So wait, what is true of that? Let's say that we have a perfect model, okay? So then for any reasonable, like any Pareto front, we should have, if you pick a specific cost, and the metric is distance from cost times score, you should never run anything that is lower cost than your expected target. You can run something that is higher cost than the expected target if the reward curve is very steep. So if you're expecting that you can do substantially better by running something that is higher cost, you will do so. So then this does incentivize you to fill out. It kind of incentivizes you to fill out the elbow, I think, of the curve a little bit, which is what we want, right? Like, if you're Pareto front, this is a train run, but imagine this is a Pareto front, then like you're gonna fill out like probably about this much of the curve, but you're not gonna fill out over here. Because like if you fill out here, you can move a little bit in the x-axis and do way better in the y-axis. There's not really a point to doing really low cost runs like this. But actually, I think this algorithm is exactly what we want in theory. And we will see why it is doing this thing now. You would not expect it to be doing really like short runs very often. I mean, it is possible it just doesn't have a great cost model yet. It's like too many short runs. Oh, no. Hang on. It's not too many short runs. It's just bad performing runs. That's different. Okay, this is actually fine. A few short runs, some long runs. Yeah, this is totally fine. And this one does quite well as well. So yeah, perfect. So yeah, we're getting like a good spread now. So we'll see whether this actually translates into good score numbers here. It seems like we're already getting like way more reasonable stuff though, right? 2, 3 of these, yeah. And then the goal of this is, as you fill in the curve, you get incentivized to find, you naturally, based on the shape of the curve, should get incentivized to find more and more time-efficient runs. Okay. Good. This is good. I don't know why it's still doing like a reasonable... Oh, see, this is not even a short run, right? This is like a long run in time steps. It's just really fast. Okay. Yeah, we're happy here. We're happy. I think that we push this. We run this on mazes and other things. I'm gonna run this not on my local so that we can actually like keep the results. And we will go from there. 5:28, got half an hour. Okay. Start by launching these runs. This one's not going to do anything because it was like optimizing, it was minimizing instead of maximizing. Boom. Okay, we're already in the TMX. Or, I don't know, just give it some name. And then this one, we also now know why this isn't working, right? Let's attach. And now this should actually be something resembling like a good sweep. Perfect. Yeah, it's a little silly to see like our sweep stuff completely breaking. But hey, it's a dev branch. We know that this algorithm works incredibly well. So as soon as this is fixed, and maybe we fix a few more small things with this, we should be getting some very good results. Yeah, why don't we open this graph up real quick? Oh yeah. We've got the baseline, we got one run that seems to match baseline here, and then we'll see how this stuff does as it runs more. No reason to keep this going on local. This will just run on this new sweep, and then next couple hours this will finish running. GPU drive stuff for Spencer. I would like to get GPU drive working on this release branch if possible. Did I PR it? Well, Spencer's gonna have new code anyways. We'll have to do like a manual merge into that. Yeah. Spencer should be back soonish, maybe? Depends how long his meeting is. Let's look at some other stuff in the meantime. So today we figured out the sweep errors. We got training running stably first of all, and then we also figured out the sweep errors for the most part. We will continue fine-tuning sweeps, but at least now it's finding like reasonable quality runs in here. We will have results by later tonight from the initial sweeps, so we can actually see what is going on. Go back to the to-dos here. There are a few small things, but I think mostly at this point it's the two things that like I think I'm like the most bottlenecked on before being able to do the release. Well, really three things. It's going to be the getting sweeps working nice and stable, which I think we hopefully have most of that working now. The rest of the general code cleanup, because like I don't want to like do the final experiment and then just do some code cleanup and screw up the results or change the results. I'd like to have most of the general code cleanup done before we lock in final results. And I guess the other thing that's just going to take a while is CUDA packaging. You know, why don't we just start looking into the CUDA packaging stuff? Because I know that's going to be a pain. So like the issue right now is we've just been shipping source for PufferLib so far. We would ideally like to ship wheels. I think for the C extensions, we can get CI build wheel working for that. But for CUDA, let me see. GitHub build CUDA extensions. Is that a thing? This is from 2021. One has to install matching CUDA system-wide. Did they ever end up doing this? Because if PyTorch included CUDA dev tools, yeah, so it is a big file as well. Okay, so they just didn't do this. Building CUDA extensions has been long. Yeah. Holy. So this just kept going on for a while. Okay, this is the exact error that I hit. This is the exact error that I hit that for like an hour yesterday. Torch version available within the isolated build environment should be the same as the outside environment. Yeah, so this is the exact thing. Okay. Did this keep going? No, I already hit the end of this. How does PyTorch do this? PyTorch, you install the version for your CUDA, right? So PyTorch just builds and ships all the binaries. Like, you don't just pip install PyTorch and expect it to work on everything, right? It works on like most cards. But like, you have to get, it only works if you have like a reasonable CUDA version. So like, yeah, this is default CUDA 12.6. So this has to match, right? And they just give a dash dash, they give an index URL. So I mean, I could do this for binaries. Let me think what the options are, right? Option 1 is we have a good CPU fallback. I wonder how bad it is if you use the CPU version, right? We could probably optimize it so that the CPU fallback is not bad, right? And then, no, because the thing is when you pip install it, if you pip install PufferLib, then you still will not have, you still just won't have access to the CUDA version, like the CUDA dev most of the time. Okay, so if you pip install without CUDA dev, then you get the CPU version. If you pip install with CUDA dev, then you get the GPU version. We could do that. And that's still just shipping SDist, I guess. It would be such a better user experience, though. Like, tremendously better user experience if you could just pip install the thing that you want and it works. So then that requires me shipping for every Python version and every CUDA version. It's annoying that you have to build it on a system with a GPU, right? That doesn't seem like you should have to do that. You have to build Can you automate CUDA builds? Automate CUDA builds GitHub. Hang on, is this a thing? Can there be like a GitHub action to... I mean, you just need to build from like a certain, like different Dockers or whatever, right? I mean, the best case scenario here, right? What I would like for puffers, I'd like you to just be able to, kind of like you do with Torch, you pip install PufferLib, you make sure that you get the one for your Torch drivers if it's different from the current defaults, and then you call it a day. I don't want to have to manually go and like spin up VMs and do all of that. Because it's like for every... So what would it be? I think it's like for every CUDA version that you have, you spin up a different dev container minimum, right? And then let's say that you have like multiple different Pythons installed. So then you need one container for each CUDA version you ship, and then from each of those you're gonna ship. Let's say we do like Python 3, 10, 11, 12, maybe 13. So like however many versions of Python we're gonna support as well. And then if none of those work, then it has to go to the fallback, which is just going to install the CPU version of our extension, and will work as long as you have GCC. Okay, so I have an idea of how we can automate the builds. Can you do like CI build wheel CUDA? Okay, so this is something, right? Working examples, translate to. So they do this, right? Pip install, and I guess they ship kernels. So they have like an action or something. Should be in actions or whatever in here, shouldn't there? Apparently you can do it. Is this the only one that has CUDA listed? It is. Many Linux. Filed for multiple GPU architectures. Okay, I don't usually like do this type of stuff, so let me see if we can figure something out. And it looks like we're gonna have to do the GPU drive stuff after after dinner. So the plan is I'm gonna look at this for a few, see if I can, because I'm gonna have to do this like probably next week. So I figured it's a good idea to take a look at what I'm dealing with. I'm gonna go get dinner in a few, and then I'm gonna be back after dinner, hopefully, if Spencer's around. Get GPU drive training very well, and to monitor the sweep results. Where do you actually see like what like scripts they're running to do this? Oh, hang on, ci.yam there, right here, right? Yeah. Okay, so this is their script. This is good, right? So this is, they have Ubuntu, runs on Ubuntu 22. They set this stuff up, so this is kind of Docker-ish. Build Python wheels. So they build this super old mini Linux thing, right? They also have Docker pushes. You know, this type of stuff I think we could actually benefit from. I don't really like having like a bunch of automated testing and stuff. It like adds a lot of overhead to dev. But for like DevOps specifically, I mean, I wouldn't mind having to not having to build the darn Dockers manually, and just having it push for us our latest containers. And then we can get our containers with a couple different CUDA versions actually. So we would have like different containers shipped. So then that solves the Docker issue, right? You include different bases. And then the actual build. I mean, the thing that would be ideal, right, is if you you could just like you specify your Docker M's, right? Like several different Docker M's, and then you just build the binaries and upload them based on those Dockers, right? Because like if you're gonna go build a few different Dockers anyways, you can just build your wheels on those Dockers. Okay. I think I'm going to have to invest some more time into like doing the CI stuff. I really don't. I've done almost none because I do not like CI for tests and stuff or Puffer. It's just like, you know, you maintain the test and then you end up having to like do a bunch of dev work to maintain the tests. It's like I have a few tests on pieces of code that I know are very fiddly, and I work very hard to minimize the number of pieces of fiddly code. But I think for this actually can make sense because this is more like workflow automation stuff, right? Where like you have to have CUDA setups for a few different versions, and this actually should make it pretty straightforward. Oh, hey Spencer, you're back. God damn it. Okay. Where are you? Hey Spencer.
Hey, what's up?
I'm probably gonna have to go for dinner in like 5, but
Yeah, no worries. I just wanted to clarify a couple things, and then
yeah,
we can
let's do that, and then we'll fix after dinner. I will hop back in here and we'll fix stuff.
Yeah, no worries. I'll probably go grab dinner at some point as well, anyways. Okay, so I got respawning going, right? And I just reset it to the original trajectory and all the things as if it would respawn perfectly.
Okay.
Um, I changed the score metric to be if it reached the goal throughout the length of the entire episode, which is the 91 step segment, right?
Yeah.
And then do we want to continuously reward it
No.
if it hits the goal after already hitting the goal once, like during the respawn?
It hits the goal, and then it
It respawns,
respawns, and then it's not
and it
off the
hits the goal
goal.
again.
Well, it takes a while to go hit the goal again, right?
Some are really close, some are far.
Yeah, that's fine though. It can get a reward for it gets a reward once when it hits the goal, and then it respawns, and then if it hits it again, it gets one reward. It doesn't get a reward for like sitting there repeatedly, right? It respawns every time it gets it once.
Yeah, it would just respawn and then it would get a reward every time it
Yes,
hits the
that is
goal.
fine. Do that.
Okay. Did that. Observations, I don't think should meaningfully change. The only thing I did is I made sure that we're no longer skipping obs after where there I took out the masking. I removed
It's gonna make it so
done.
much easier.
Terminals aren't used at all, yeah? And
They are. Well, technically, it should be yeah, it's well, you can set the agent being done whenever it hits the goal, technically, and you could set truncated whenever you hit the 91 steps. We do not use truncated at the moment. We do use terminals. It is used in the advantage function calculation.
okay, so
Oftentimes
in
things will train perfectly well without it, but technically the correct thing to do is to set it.
okay, I will leave it out for now.
That is fine.
Initial run did not get to from using the same params, was not able to get to
What did it
whatever the
get?
88% that we got. It capped at like 40 or something.
What's the
So I'm
curve?
seeing right now, huh?
What's the curve?
Um, Let me just run one right now. I didn't put a curve on it. When I saw it got to 40, I just went back to seeing if I had a bug somewhere.
Okay. It should be like substantially better.
That's what I wanted to kind of just make sure I got it.
You might want to
Versions
set
are
the
current.
duns, but
Yeah, I might set duns. I mean, I guess I could set duns when it reached the goal. That way, at least it can know to take it to calculate its advantages on that group of time steps.
yeah, if it hits the goal, you can set done is good.
Let's see. There's
I mean,
anything else in here?
my personal theory is with the LSTM, it really shouldn't freaking matter. But like, I don't know. I've had like academic people be like, like incensed that I have done such a thing.
Fair enough. Fair enough. Um,
Mhm.
okay. I mean, I think respawn should be fairly simple. I don't see any other reasons why this would be demonstrably worse without
Did you
masking.
render it?
Oh, hold up. Should I take out the? Is there any reason to take out the max at all
What
on
max?
the max pooling, or should we still keep that there?
Why would you take that out?
Well, I don't see a particular reason for it right now. No,
What do you
I
mean?
mean,
The max
isn't
pooling,
it just
it's like max pooling or flatten, right?
yeah?
And if you flatten, it's gigantic. If you flatten like 32x64, then you have to do 32 times 64 as a hidden layer to the next linear. Right? So that's a 1800 hidden layer, just off of that.
Okay. Fair enough. That is very big.
And also you lose order and you lose the ordering as well. The order invariance.
Okay. Let me ship over this. All right, where is this? We're in general chat. It's like 3 minutes into its 7-minute run.
Let me see. Is it in Gen chat or is it in the voice? Some voice?
The gen, whatever we're in, the gen chat.
Okay, yeah, I think I see it. So this is...
But this is not really doing too hot.
No.
It could be the way I'm just representing score though.
What do you mean?
So
When do you add a log?
I am adding a log at the end of the 91 second.
Well, that's why. You need to add a log every time the agent either collides or reaches the goal.
Oh, okay, never mind. I was being an idiot. I did not reset on collision because I was thinking collisions were off.
Okay, so that's one thing. And the other thing is, like, since the agents are no longer, like, get to goal and stay at goal, like, you gotta add the logs whenever the agent dies, like, either, like, it gets to the goal or it collides, right? Like, that's essentially your agent rollout now.
I mean, I could do it at if the way I order it, so say like I set like an environment variable to track if the goal has been reached or if it's been collided. Like it would set it in somewhere later in step whenever that happens, and then when you go back to the start of the next step, it would.
Okay, there are a couple ways you could do it. The way I was suggesting is technically harder than the one that NYU has set up, but I think we would still full solve.
I
got-
always thought if you're calling add log this many times, like some like the indexing of it gets all funky.
No, it shouldn't.
Well,
I gotta run for dinner though, so
okay,
I will.
no worries.
I'll be back on after for the folks on YouTube. This is all open source RL dev. You can check this out at puffer.ai. Start the GitHub to help us out. Join the Discord if you want to get involved with develop it. Thanks.